Hi, I'm Tom and I talk about code. Welcome back to another Rust programming livestream. Today, even more work on my compiler. Last time, we left things with a pretty nasty pointer arithmetic bug. I did a lot of really good work. I fixed a lot of very subtle issues that I probably should be picking up in tests, but I'm not. That's okay. We'll live with that. But I think today I want to try and fix some of these pointer issues. I maybe need to write some better tests that will help me hone in on exactly what's going wrong. I'm just reusing the same base slide because I think some of this stuff is still going to be relevant. The goal is still to finish strings, right? I want to do hello world. I've kind of done hello world already like a month or two ago, but I really want to do hello world from a string that's compiled into the binary. That is another level of goal. I just want to make sure my microphone's set up well. Awesome. But I have done a bit of work off camera. Not on this bug, but on slightly related stuff. So I'm gonna compile a program, copy it to the clipboard, and this is what the new front end looks like. It's very similar to the old front end, but I can load a binary, I can look at the code, I should be able to tick through this and see highlighting. So this is what my old UI did, but it's all using Vue 3 now, so it's all reactive. So this, instead of document get element by ID, it just like matches a property of this line with the current program counter, which is really cool. And it kind of conditionally applies a class. So it jumps around, it does a bunch of stuff. We don't have debug labels yet because we're not putting them into the binary, and this is loaded from an actual compiled, like this is a compiled binary with a header and the string and everything. And at a certain point, this is going to blow up if I tick through. I don't have a run button yet. I don't have a run, run until whatever. I need to add breakpoints as well. Breakpoints are going to be a lot easier in this UI, which is very exciting. So if I run this enough, we're going to hit this point where, this is like a stack pointer, I guess, right? The B register, it's pointing to something on the stack. Ideally, these should be reactive as well. We should be able to, type in to a box here and have this reflected in the actual state of the machine, but that's neither here nor there. It's another day's problem. For now, it's just a big wall of text. That's okay. Yeah, awesome. So we load this funky address into C, and then at PC300, we try and store something to address C. We try and store 10 at address C. Okay? And 9EF4. So what is this error? Where does this error come from? This error comes from memory error, translation at whatever. So where does address translation error? It takes an address and it takes an address local, right? So this is the address we're trying to save to, and this is the address relative to the actual block of the thing, right? The start of the block we're looking at. So we're trying to write 1,000, and I'm pretty sure that if I look at Python and I go A1, 2, 3, 4, I'm gonna get a different number. Oh, what is hex of this number? Bobius, welcome, how you going? E1000. Okay, I don't know where 1,000 is coming from. That's a bit weird. That's very weird. Okay, either way, the machine that's running here is actually not set up to run this program. And this is more stuff we need to kind of communicate at a binary level, like what hardware interfaces do we expect. So instead of running this in the browser UI, which is still a big whip, I'm just going to run it in bin VM. And we get this instead, which is interesting. And we can kind of see the same state. Like we're in exactly the same state here. No, we're not. The program counter is different. This crashes at a very different point. But with, interestingly, the same value in the C register. Curious. That's very curious. What's at 192? Is 192 also a store like this? It is. Okay, so whatever we're doing, it happens twice. It happens twice. I don't know if this one is later than... Weird. Maybe this one at 300 is actually okay in the console virtual machine because the hardware configuration is slightly different. 14. I don't know where address 300. Okay, I need to search for this. PC 300. Can we find anywhere that the program counter is set to 300? No. We can find their program counter, let's say 316. What is going on here? PC 316. We can find that, but we can't find 300. Okay, so this crashes, the terminal 1 crashes earlier than this for some reason, probably, which is weird and uncool, but that's good to know. It's good to know. So why does this blow up? Well, it blows up because we're trying to, because we pop something from the stack, and I think we worked out this is likely stack corruption. This is likely popping a thing off of the stack that's not supposed to be popped. So we just end up with some garbage. Because this number is just very, very large, right? This is, I don't think it's large enough to be a negative number, but it's very, very large. 660000. Now, this is a hex number, right? I think we worked that out too, because we can see in the formatter for this, it prints it out as a hex number. Invalid out of bounds also prints it as hex. So these are 2 hex numbers. That's important to know. So how do we get 66,000? Because this means we're reading something from a different page, right? Remember, addresses are 32 bits, but our registers are only 16 bits. So how have we ended up in this situation where we're trying to read something from anything other than the 0 page? That's a very good question. So what this actually means is, this is an instruction that I did not rewrite when I reordered my instruction set. Because I changed all my instructions, right? I rewrote all my instructions so that they were consistent with what order they operated on data. So I think if we go into vm.rs, not vm.c, I don't know why it would be in .c, store byte, right? So we have the source, and then we have the base and the page. What do we have here? We have, yeah, so this instruction was obviously written at a point in the compiler when this was the base, this was the page, and this was the source, but now B should come first. So we need to find where we're omitting this instruction. We need to find this dud store byte instruction. So what we're going to do, we're going to grep rn for store byte in our compiler. We only have one store byte instruction. That's very, very good news. We can deal with that. Where is it? 146. So that's in util, I think. No, it wasn't. Yeah, there's 2 utils. Store byte. Here we go. So actually, I think it's just like this, right? And indeed, we rewrote store word, we just didn't rewrite store byte, right? Store word had already had this refactor done where the value was now the first thing. So that's cool. And the reason it's like this is because when we load, we want the destination to be the first register, because that is the convention that we've gone with, just in my language, right? That's what I've decided to do. The source always the destination, sorry, always comes first. And so it makes sense that store and load have the address in the same place. Cool, okay. So let's recompile and rerun that and see what happens. And that runs to completion. Wow, is it really that simple? Was that really, what an odd problem to have. Let's go back to my VM and let's just get rid of this weird println. I need this to be configurable, right? I need some kind of verbose mode that I can toggle and control, but I don't have that right now, so I'm just manually commenting out a println. Oh my gosh, I think it works. I think it works. That's incredible. Test.code, let's change one of our strings to hello world. Now, obviously, we have some issues formatting numbers that are bigger than 10, because this is 5, 6, 7, 8, 9, 10, 11. This is 12 long. So I'm guessing that immediately after our digits, we start going into characters like this. So that's a bug that needs to be fixed. Asterlen doesn't really work, but this program does. And I'm going to commit this, and I'm going to say that strings... Well, no, okay, hold on. Sorry. One more thing. Let's write a test for strings. And we'll put this in test. Where does this go? Maybe this needs a new thing. Maybe this needs a tests string.rs. Because strings are complicated. Let's copy a function test. Cool. We need all this stuff. Okay, and this will be, I guess, hello world, right? This is the most simple test we could do. Get rid of all this garbage. We want to go into test.code. We want to copy a bunch of stuff. We want to put it in here. Okay, so we want strlen, we want print, we want println as well. We don't need putch. We'll get rid of putch. I mean, I guess we could use putch instead of this, but we won't. We won't. I like assigning to pointers directly. I think that's fun. Now, I think, I need to escape my quotes. This is going to be fun. This is almost certainly going to lead to problems. Yeah, that's so good. That's amazing. That's amazing. I'm so happy that this worked. Bobius, how are you going? How is your Zig journey going, by the way? Bobius has been investigating Zig and reporting back on his experience in my Discord. And sounds like there's some rough edges. Have you made any Zig progress? I would love to hear about Zig. Because I would love to do some Zig streams. I think that would be a lot of fun. Okay, so we're just going to do hello world. We're going to println this, and then we're going to return strlen of this. Right? That's all we're doing. That's all we're doing. So we're verifying we get the string length. We're verifying that we can print it out. Actually, we're not verifying that we can print it out. We should be able to test, for example, so we should be able to say assert printed VM right? We should be able to say this. This would be useful. But I think we can do this with an equality test. For now, let's just do this and verify that it compiles and runs, and it should probably blow up in some way. Actually, maybe more than one test will blow up, because we did change a couple of things here. What has blown up here? What on earth? Hello world fails. It fails to compile. Why does it fail to compile? Println, string, strlen. Okay, what is this saying? Unknown function putch. Where did putch come from? Oh yeah, right. Okay, well we'll just get rid of println. Who cares if there's a new line? That's not what I'm about. Okay, cool. Cool. Okay, this is good, right? We can't run it because this thing doesn't exist. Bobius says, after messing around with parser combinators in Zig, you gave up and started writing a standard hand-rolled tokenizer in parser. Yeah, awesome. That is completely valid, and you might have an easier time with it than trying to do it the other way, which is very funny. Very, very funny. Okay, so let's look at my common, because we have map define blah 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 to binary. Yeah, okay, so load to VM actually handles all of the array bindings now, right? Because if we have a section that defines a heap, we map it there. So I want to call an additional VM map. I want to say let VM I want an IO device. I want an IO device that's gonna memory. No, it's in bin VM IO device. It's this print device. So what I really want here is a device that's gonna put everything it gets into a buffer, and we can write that. We can write that. Let's put it in common. Let's put it in lang tests common. Let's say pub struct IO to buff. Let's call it IO to buffer, and then we'll have an underlying data structure, an underlying data element that's just a vec of bytes that get written. We will impl addressable for IO to buffer. Maybe we'll just call it like terminal buffer. Right, where if we read and write to it, it just puts terminal byte buffer. Does that work? I think that works. And then we'll go into bin VM. We're going to copy and paste this implementation because it's pretty much the same. If we read, we just give back 0. If we print, we're gonna, instead of doing this, we're just gonna say self.data.push value. Beautiful. Awesome. So any reads and writes to this device will just append to its data. After messing around, you were going to use the Mecha library. You had issues dealing with recursive cases, even write recursive. Yeah. You know, Zig is very C-like. I don't know if the type system is as powerful as you need to do this really sensibly. Okay, beautiful. At some point I re-enabled my mouse cursor, right? I think when I recorded my Eevee video. How do people feel about mouse cursor? Do they want to see it? Because I'm doing Vim, so I'm not like touching the mouse a whole heap. I'm more than I probably should be at the moment. I've got a mouse plugged in, and it just kind of, it's like it's brain rot. It just it invites you to touch it. Cool. So terminal byte buffer is going to work. We're going to have everything we need here. Let's look at our string examples. We are going to have it. So we'll say let. Actually, we should derive default for this as well. So we can say bb equals terminal byte buffer default. Then we're going to map this in at address E1000. It's going to be size 1, and it's going to be a box new of bb. And then we also want to assert at the end VM. No, we want to say bb.data.to. Can we toString a vec of U8? That would be really great. Rust vec U8 to string. I want to get it. I want to reinterpret it. You like seeing cursors? Seeing things happen without a mouse feels vaguely wrong. Well, you know, welcome to NeoVim. But yeah, I worry it's distracting. Stir from UTF-8. Sorry. Let's say stir from UTF-8. It's actually from ASCII, but whatever. That will be the same thing, I guess. I think I probably want to borrow this, and then I want it to say hello world with an exclamation mark. Cool. Now let's test this out and see what happens. Use std stir. Unwrap. Nice. This obviously needs to be mutable because we're mapping something new into it. And actually we're running a program in here, so that doesn't work anyway. Lang common. So I want to decompose this into 2 parts, right? I want to compose this into the build machine and run program part. So let's say pub fn build machine. This will take a program. Right, so I just want to decompose this into 2 parts so that some tests have the option of not just running it straight out the gate. Cool, that is good. So we want to copy and paste the first half of this up until here. And then we want the other half of this to be pub fn run, what do I call this? Maybe execute program. And this should take a mutable reference to a machine and give us back something to do with that machine. Actually, it probably... Let's get... No, yeah, no, we don't need to give back anything. Is halt, that's okay, so we just give back okay. Step is important. Excellent, excellent. We check for a max cycle count. And so then what run program now does, pub run program, which takes a program as a stir, and it gives us back a result machine string. But rather than doing everything the fancy way, now it just says let VM equal build machine, and then execute loaded program, borrowing it mutably, and then we just say okay VM. Beautiful. That's it. Job done. Job done. This will certainly not work. I've done something wrong. Implicitly returns. Yep. So we need to say okay VM. And this is not complete because it needs that. Implicitly returns blah. Run program. This is an extra semicolon. Nice. Okay, this is looking good. BB not found in this scope. How did that happen? Because I deleted it. BB. So now instead of this, what I want to say is build. What did I say? Build machine. Right, and so when we build the machine, we bake the test case into it, because I think that's cool. I think that makes sense. Now we make a thing that is a terminal buffer, whatever I called this thing. Terminal byte buffer, which is an awful name. You know, when you're naming things in your code bases, do better than me. Okay, that's my advice. That's my advice. Sorry, just have to quickly check on my... Cool. I forgot I have dinner plans and I haven't booked a table. Hopefully going out for all-you-can-eat Sri Lankan tonight, which is going to be really fun. Okay, so we make a box, we get a reference to this thing, we map it in, that all sounds good, except then we're missing the step where we say execute loaded program. God, what did I call these things? Execute loaded program. Execute loaded execute. Nice. The value is moved. Of course it's moved. How do I deal with that? Hadn't thought this far ahead. Hadn't thought this far ahead. Can I... Oh shit. How do I do this? What I need here is everyone's friend... Well, it feels like, because I move here, it feels like what I need is some kind of ref cell, right? But I don't know if I can put a ref cell in here. Can I implement address? Can I make every ref cell T addressable if... Maybe ref cell has that. Let me wrap it in a ref cell and see what happens. Ref cell new. I think I need to import ref cell, right? Yeah, cool. So use std. Is that it? Yeah, cool. Okay, so can I implement, let's go into memory. Trait addressable. Can I say impl addressable for f, where f, for f, where f is... Does this make sense? Can I implement this for any type that implements addressable? Right? And then just these functions... Is this sensible Rust? Does this work? Where we just like borrow mutably and then call read on it, right? And if you've passed a ref cell in, you're assuming ownership of this disaster. Can we do this? Sorry, yeah, Bobius. This is a rhetorical question. I just have to ask myself to confirm that it's okay. Solve.bromut.0 all. Okay, beautiful. Let's see what happens when I build this. And we've already included refcell. Where else does refcell fuck? Oh yeah, the record. Cool. Mm-hmm. Oh yeah, so this is a generic. We have to be generic here. And that works. Insane. I can't believe that works. Borrow. Okay. Value moved. Okay, so we still move it into the box. That's, can I clone? Can I clone a ref cell like that? It's because the ref cell's inside a box. We're passing the actual value. Oh, that's rough. Execute load program. So what's going on here? What's going on here? And what's interesting is I actually have a ref cell here already. So maybe I just need to expose the ref cell part of it. Nathan Day, welcome. Have I tried to get Rust running on PS2 hardware? No. Porting LLVM to the PlayStation 2 is extremely non-trivial. Someone has tried, and they got some basic stuff running, but it's such a monumental project. I'm not prepared to spend 2 years porting, not 2 years, but you know, like at the rate I go, it would probably take me 2 years. The LLVM port is the big thing, and the thing that would be really hard about it is Rust has its own LLVM fork, so porting a fork of LLVM that Rust maintains, like, if I was gonna do it, I would want to port LLVM outright to compile for the very quirky PlayStation 2 CPU. There's a bunch of problems. The PlayStation 2 CPU has really weird floats, and I just don't know how you would support it. So yeah, it's not an easy architecture. I would have to learn so much about LLVM code gen. It's a cool idea if I'm gonna do it, and this is a spoiler for a future video idea that I want to make. Maybe a live stream, maybe a YouTube video. But you could do it via WASM. Haven't done it yet, but that is, you know, you could port a WASM engine to the PlayStation 2 and compile Rust to WASM and do that. That would be fun. That's something I would really like to do, but not there yet. There's a few things that need to happen for me to get there. But that would be fun, especially to tie into my existing PlayStation 2 engine, which is now... I've done some big refactors. If you go check out the code, I think they're all pushed up now. But basically, it's now a bit more decoupled from Lua. The Lua's there if you want it, but you can just statically build everything without Lua. So I've got a little roguelike, a little like ASCII character-based roguelike that I'm playing around with that is just C, and it's a much better starting point, a much better example for people to look at. So it's in a good place. It's in a good place, and it's getting better every time I touch it. I'm ready to do the next part of vector unit dev, and I want to do that live stream, and I'm just waiting for a day where I can block out like 5 or 6 hours to do it. But that's coming soon. That's in the future. Cool. All right. My friend is going to call and book the Sri Lankan place for me. That is a good outcome. So we take a box of an addressable and then we turn it into a ref cell. So what I actually want to do is... So hold on. So Rust copy ref cell. I want to be able to make a copy of a... Maybe that doesn't work though. Ref cell... pointer, that's okay. Borrow. So the idea is that we are taking runtime. Yeah, okay. So I need to like wrap it in RC or something. The fact that it's a box of ref cell is what doesn't work here. So unless I need a version of this, right? Map, I'll call it map ref, and this will be a version of map where we will pass a ref cell in directly. And this is rarely an API that will get used unless you care about reading a result back from the actual data. So this is going to look really similar, right? Dyn addressable. Can I? No, hold on. That's not what I want. I want a ref cell Dyn addressable, right? So we're passing a ref cell in directly. Okay. This is going to allow us to do something. This is going to allow us to do something. What does this change? What does this change? This means that we are passing in... No, hold on, sorry. We're passing in a box of a ref cell, right? So rather than... no, a ref cell of a box. What am I doing? A ref... Wait. Yeah, because before I was passing in... Yeah. Before I was passing in, wait, this still won't work, will it? Because the addressable's still wrapped in a... Let's try this. But because I'm moving the ref cell here, I still think this doesn't work. I need this to be an RC of a ref cell. So I'm passing... Hold on, I gotta draw this. Rust breaks my brain sometimes. So we have an addressable A, okay? And this lives on the heap because it's in a box. We're gonna draw a nice little box around it, right? So A is in a box on the heap. What I want to be able to do is have a thing, let's call it R0, that points to this box. And I also want to be able to have an R1 that points to this box. And I want to move R1 into the context of my VM and then run the VM, and then read the result out from R0. This is like putting, this is like if you have a hat, right? I want to, how do you draw a hat? What am I doing? If you have like a top hat, right? Like this. And I want to put a rabbit inside this hat. I want the rabbit to go in here, and I want it to come out of a second hat. That's basically what I'm describing, right? Because they're both intrinsically tied to the same physical location somewhere in the ether. Right? This is the scenario. GCC supports PS2 architecture. GCC internals wouldn't be particularly helpful. Yeah, exactly. The GCC port's really good. It's the PS2 dev. It actually uses extremely modern GCC, so you can use like C generic. You can use any C11, C. I think they're up. Hold on. What version? PS2 dev. What version of GCC are we on? Scripts. What do we build? Toolchain. PS2 toolchain repo. Okay, that didn't work. That didn't do what I thought it did. I don't know. I can't remember. But yeah, it's very... Couldn't I use MPSC to move the rabbit? MPSC. Ah, okay. Message-based. Message-based would work, right? But I would rather not use a channel for this because I shouldn't need to, right? Isn't there... So what... Ref cell... Hold on. So shareable mutable containers. Isn't this what ref cell does? Shareable mutable containers. So types may be mutated through shared references. Interior mutability. Lifetimes, dynamic borrowing, tracked at runtime. So you can have two ref cells to the same T. Obtainable via borrow. Yeah, so the problem is the ownership here, right? The fact that this mapper owns this thing. This is the problem. So this is a good suggestion, but I don't think it's the right answer to this problem. I think the whole... What has happened? It's the fact that... like you can wrap a ref cell in an RC, right? That would kind of solve this as well, because then I could clone an RC that contains a ref cell. The problem is the ownership of the actual ref cell is being moved. Or well, in this case, it's being created, right? So the data, the underlying box is moved, and then the ref cell is created around it. If I create a ref cell, but what I want is to be able to clone a ref cell, right? And ref cell's impl clone. Ref cell's impl clone. So this is actually what I want. This is exactly what I want. I want exactly this and nothing else. For some reason that I can probably guess at, the thing didn't work for. Okay. Wait, is this because... No, yeah, this should be fine. This should be fine. It doesn't matter if T is clonable. We should be able to pass a ref cell in directly, and it's a cloned thing. This should be okay. So let's find map vm.rs map, and let's do the same thing here. We're going to copy and paste. We're going to add a function called map ref, which takes a ref cell of a box of dynaddressable, because it has to, because that's the type of this. Has to be wrapped in a box. And we're going to say map ref. Okay, so now in our test case, we can say, instead of map, we should be able to say map ref. And let's see what happens. Let's see what happens. Ref cell not found in the scope. That's good. I can do with that. Use cell ref cell. Okay, map ref not found in the scope because I need to say memory. Cool. Nice, nice. Now we have this copy trait. Y copy clone. There we go. Clone box. So the problem's the box, right? Like we can try and clone it, but I would have thought we were allowed to clone a ref cell of box. I thought that would be okay. Trait bound. So what's the trait bound? Box. Yeah, box must implement clone. Oh. I thought the point of ref cell was it kind of got around this, right? Show me the ref cell examples. Show me the ref cell examples again. RC ref cell. So and this is why you see RC of ref cell, right? This is why you see ref cells wrapped in RCs. Okay, I'm gonna do the stupidest possible thing. I have to wrap it in a box because otherwise we can't pass it, right? Can I... Actually, maybe it can just be a ref cell T. Maybe I just have to accept that on the cooler, right? So what if I do... This is going to break a bunch of other code. Let's try this. Let's see what happens. Right? But make it a ref cell and map it indirectly. And then we still have an owned copy of this, right? Can we do that? Can we try that? I think that works. I think that's okay. I think that should be fine, right? There's an indirection here. The problem was, I guess, the ref cell didn't have that indirection. I think that's what happened. I feel like that defeats... I feel like the problem is that I don't know, like I don't understand what the problem with what I had there was, honestly. I'm just gonna see if this works. So this is gonna break, and this is gonna yell at me because it has the wrong function signature. Make T, yeah, there we go. I was like, surely that didn't compile. So we need stdrc, rc. Cool. Sorry to check my phone again. This should be the last time. It's really funny. I've been talking to this friend about this all you can eat Sri Lankan buffet since basically he moved to Australia, and we're finally going. It's well overdue. Space Nerde followed me. Thank you very much for the follow. Thank you very much for the useful suggestion about MPSC. That is cool, and I haven't really looked at it before. So we're gonna dive back into these memory APIs, okay? And now instead of this, we're gonna see if we can pass in a ref cell directly and change this. So can we do this? Or does it need to be a ref cell of box, right? We'll find out. We'll find out. If the type checker yells at us, we'll find out. So this is like saying RC new, and this one now, instead of, we're getting rid of one inner layer. I suspect that box might actually have significance. But here we're passing in the RC directly, right? So now in the VM, we need to find every function called map, and update this accordingly. Ref cell A, that's good. And then map ref cell A, and then then this needs to be an RC of ref cell, the one where we don't take ownership. Okay, what do we get? RC not found in the scope. That's okay, we can import it. What else do we get? RC not found in the scope. That's okay, we can import it. Okay, arguments of this method are incorrect because we're using it places. Let's make B and just fix all of this stuff. Okay, doesn't have a type known. So this is the problem, right? This is what I was saying. Now, we have to add box back in. We have to add a box back in. That's okay. That's fine. We have to add we have to add a box back in. Because ref cell T, yeah, it doesn't have its type known. It has to be wrapped in a box. That's what puts it on the heap. So there is something about ref cell I obviously don't understand still. Ref cell is just the ref part, I guess, not the actual on the heap part. So now these functions in vm.rs need to be a box T as well. Cool. This needs to be a box. Okay, what do we get? Box linear memory. So this needs to be a ref cell. Maybe not actually. Maybe I can go back to doing it this way. Hold on. Because the things that don't need to have a reference, right? This is like, take this thing in, do whatever you want with it, but also we're going to support a different API that lets you keep a reference to the thing that you're mapping in so that you can do stuff with it. You can do weird memory stuff. So let's go back to map. Let's just make it take a box T, and we'll go RC new ref cell new, because I want to keep this mess as separate from the consumers as possible. Okay, addressable is not implemented for box addressable. What does that mean? Mapped push, mapped. Ah, yes, okay. Because this is missing a layer. Easy. That's always the answer, right? Miss something easy. Cool. Nice, we're getting close, we're getting close. Expected RC ref cell. Yep, this is because we're missing a layer. We're missing a box new. This is the most disgusting type I've ever written, but it works. RC found RC ref cell, blah, blah, blah. So box. Interesting. Don't say plus static. Expected plus static. Why does this have a static lifetime? Common implements addressable. You could box the found value and coerce it to the trait object. You'll have to change the expected type as well. What? What? Hold on. Can you repeat that for me? What? This, yeah, what? How do I even parse this? What does this mean? Because it's boxed, right? Like, why does this have this? What terminal byte buffer implements addressable? So I could box the found value. What's the found value? Is the found value the thing in this box? Okay, have I wrapped this in too many types? Does this no longer understand? RC ref cell box. RC ref cell box. Oh my god, I am gonna go crazy. I don't understand. Why is there a lifetime associated with this? Right? Turned into a trait object. What does this mean? How do I turn it into it? What's a trait object versus a boxception? Why? I don't understand why it's telling me to box the value because it's in a box. I don't want to put it in a second box. That would be excessive. You'll have to change the expected types of Vibane trait object. What is a trait object? Oops. Something with Dyn. But isn't this what I'm doing? Right? Isn't this? Oh, I think I see what I have to do. Ref cell box Dyn addressable. Is this what you mean? Like, don't let it try and work this out at runtime. Tell it exactly what it should be. Don't know why my window moved there. Dyn address. Yeah. Okay. So, addressable. Simple VM memory well, actually it should just be simple VM addressable. There we go. bb.borrow.data. What is bb.borrow? Whoa, where did this come from? Get rid of this bookmark. Okay, that fixed it. Thank you, Vibane. That was a very useful suggestion. It got me there. In a way I didn't expect. It got me there. Let's find the docs for RC. Does RC have a borrow method? It does. And it gives us back a ref t. So I need to .borrow again, basically. Make t. No. Borrow is ref. Okay, so what is this? No field data on ref box Dyn address. Oh no, but now it's not. Now I can't. The whole point of this was to use it. So can I unsafe cast Rust unsafe cast trait object to concrete type? Because I'll do this unsafe. This is a test. I don't give a shit. It just means this whole API isn't useful for what I want it to be useful for, right? Because the whole point is I'm meant to be able to get the thing inside the box. But if the compiler won't let me do that, you could. There's just all these little rough edges in Rust that I'm still finding, right? That's, oh yeah, reference to a concrete type. Yeah, that's kind of what I want, right? Box Dyn A as box B. Yeah, so downcast ref. Let me try this. So I want to say dot as, and this isn't unsafe. Downcast. It just might blow up. So let's match bb.borrow dot as any dot downcast ref terminal byte buffer what a function signature, some t. Yeah, absolutely, absolutely. It's like a cascading failure, right? Like you do one thing weird, so you do something else weird. I think I have a better understanding of this now. This whole memory thing, this whole API was really winging it. I didn't understand why I put a ref cell here at all. So this actually does work, right? And I can do this downcast at runtime, and it will work. It just feels like I'm building layers of Jinx. So this needs me to go back in and think about it. It needs a level of thought that I'm not prepared for right now. T.data. Here we go. Here we go. Could not get data back. Let's say that. Okay. I found : downcast ref. That looks. Oh right, I always put extra colons here for some reason. Thank you, Bobbicools. Bobbius. Sorry, wrong Bob. There's another Bob that hangs out here sometimes. Okay, not found in. So I want to maybe move out of the RC. Can I? What about this? Won't work, will it? Because this is still going to be outside of the thing. RC, yeah. Impossible to move value out of an RC. Okay, this still doesn't work. This still doesn't work. I didn't think about this step. Get a copy. T clone, borrow clone. This won't work, will it? Oh no. Oh no, it doesn't work. I still can't get what I put. The whole point is that this should be able to, what am I even saying? This should, it's rabbits in a hat. This is literally what, I couldn't give a better example than this. So what I'm trying to achieve with RC is to make these two references, right? Like this is the first RC, this is the second RC, and they both point to the same thing. So in other words, I can put a rabbit into one hat and take it out the other, as long as I'm not trying to use both hats at the same time. That's the only level of indirection I want here. What's actually happened, I think, is we end up with our data, let's call this R0. This is like our prime data that has our box in it, right? One problem is that we have at this point forgotten what's inside the box, and we can no longer use it as the thing that I want to use it as. We then from here generate a derivative R1 which also has access to the box, right? This is the same box. If we put a rabbit into the hat over here, the rabbit, like it's the same box. It's the same, it occupies the same space. The problem is, once we're done with these, I want to be able to reach into here and take this thing out. And RC doesn't let you do that, because RC can't guarantee, and it doesn't have this like runtime panic thing that a ref cell does. So what's going on? How do I do this indirection, right? What type allows me to, I guess, sever the link on one hand, but essentially defer this to check to runtime. RC does not defer the check. You can still access it, but I can't, well, can I borrow out of it? Maybe I have to borrow, can I do this cast if I just borrow it? Can I, okay, that's a good point. Maybe I'm overcomplicating it. Can I, but I don't know if the cast I want to do is going to work, because I can't clone it because there's a box in the chain, right? That's basically my concern. Let's find out. Let's find out. So what do I do? Do I just dot borrow? Which is what I'm doing, right? So when I borrow it, I get a ref to this. So what do I do from ref? How do I get from ref to... wait, what was this being called on? This was being called on a... This is being called... Yeah, so this... I want to call a method on this box inside the ref, right? So how do I... What does ref let me do? Cell ref. I'm not really sure what ref does. A borrowed reference to a value in a ref cell box. Doesn't really tell me much about it. A runtime borrow? Yeah. So I should be able to... So why can't I call as any, right? Because as any... Does this function not exist anymore? Has it been renamed? Does that make sense? Is that just the problem? Yeah, this function. Wow. Incredible. The function doesn't exist because it's not called that. So downcast returns... What is this result type? Downcast string. Or it gives the original box. Okay, we can do that. So what I want to use downcast instead. Well, hold on. Downcast unchecked. That's okay because it's a nightly. What are the different downcasts I can do? Just these two. Okay, so let's just downcast it then. Downcast terminal byte buffer. Okay. And if we get the error back, then we panic. That's what we need. So the okay here, yeah, the okay here is a boxed value with that type. Oh my gosh. Oh my gosh. What a dilemma. But downcast T. So this looks like it should work, right? We're calling downcast on a box. Downcast not found for struct ref box, but I should be able to call the method on box, right? Except no, because it moves, right? So this is why I need to take the thing out of the RC, because this downcast moves. Is there a version of downcast that operates on a reference? And there is a function called downcast ref, presumably. Like, I assume, like, how old is this, right? (2018). So if we can... I don't think that's what I want. I've ended up over my head. RC downcast? I don't know if is that the standard type? RC downcast. What's RC downcast? No, because that's still not what I want. Cool. We are in Rust type hell. We are deep in the weeds. What do I need to do? I need to cut the stream because I need to go and eat Sri Lankan food. So I'm going to fix this off camera. I'm going to unpack this mess. I'm probably going to refactor my memory APIs so that there's an option for an unowned thing in a better way. And I'll think it through more than this mess. That was cool though. Let's find someone cool to raid. and we'll throw the love on and hopefully find a Rust streamer who is maybe struggling a little bit less than I was today. Sorry for everyone who was coming in. A couple of people came in quite late there. I want to be doing some longer streams, but hard to find the time at the moment. Cheers. I hope that was at least interesting to someone. That was not my best stream. We got a little stuck, but that's okay. It happens sometimes. Game Boy game dev and assembly? Sure. Sold. These sound like good things. We're raiding this channel. We're gonna see some assembly. We're gonna see this looks really cool. Thank you everyone for tuning in. This has been a fun adventure into madness. And let's go share some love with this channel. I will catch you all next time. Thanks to everyone who's been watching on YouTube. Bye.